Hi, in this video we are going to see the calculation of the Fourier series coefficients of the full wave rectified sine signal. First of all, let us define this signal. Now consider the pulse signal, which is composed of only the lobe of the sine function from 0 to pi. And the magnitude here is the maximum value is 1. So P of t is defined as sine t for t between 0 and pi and 0 elsewhere. So we have such a signal. Now we can obtain a periodic signal from this P of t as follows. So let x of t be equal to m from minus infinity to plus infinity, P of t minus m pi. In other words, we have the periodic extension of P of t with a period equal to pi. In other words, if we plot if we plot x of t, we are going to have the lobe repeated with a period equal to pi. So the zero crossings are at integer multiples of pi. Okay, so how can we obtain the Fourier series expression of x of t, or Fourier series representation of x of t? First of all, x of t is, as you see, equal to x of t plus pi. So this is of course valid for all values of t. So t0 equal to pi is the fundamental period. Period of this signal. Okay. Now, therefore, we are going to have the following Fourier series representation for x of t. It will be k running from minus infinity to plus infinity, ak e to j k omega 0 t. Now what is omega 0? Omega 0 is equal to 2 pi over t0, and the fundamental period t0 is equal to pi. Therefore, 2 pi over pi, in other words, omega 0 is equal to 2. So x of t is equal to k from minus infinity to plus infinity, ak e to j k 2t. Okay. Now we evaluate the coefficients, remember, by using the expression 1 over t0, and we integrate over a period from an arbitrary t0 value to t0 plus capital T0, x of t e to minus jk omega 0 t integrated with respect to t. Now, if we substitute, as you see, we have t0 is equal to pi. So we have 1 over pi. Okay, we can integrate over a period. So t0 is arbitrary, but of course the simplest possible choice is to integrate from 0 to pi. So from 0 to pi, we are going to integrate sine t e to minus jk 2t. And we are going to obtain ak in terms of the index k. Now let us see how we carry out this integration operation. Okay, now let us see the steps of the calculation of the coefficients. ak is equal to 1 over pi from 0 to pi sine t e to minus j k 2t integrated with respect to t. Now we can write down sine t in terms of a superposition of complex exponential signals as e to jt minus e to minus jt divided by 2j. So ak becomes, okay, we can take that 1 over 2j outside the integral, 1 over 2 pi j, the integral from 0 to pi, e to j 1 minus 2k t minus e to j, and we have minus 1, again we have minus 2k t integrated with respect to t. Now 1 over 2 pi j. Now the integral of these complex exponential functions can be evaluated easily as e to j 1 minus 2k t divided by j 1 minus 2k minus e to j minus 1 minus 2k t divided by j minus 1 minus 2k, and we have to evaluate this expression at the integration limits. So we have 1 over 2 pi j. Okay, when we evaluate the first term at t equal to pi, let us decompose this complex exponential as the product of two complex exponential terms and write it in that form. So we have e to j pi e to minus 2k pi. Of course, we have also j with a minus sign, divided by j 1 minus 2k. And similarly, here we have, also we have to evaluate the function at 0. So we have, when we substitute 0 in the exponent, we have an integer multiple of 0 times j, so e to j 0 is 1. So we have minus 1 here. And minus, for the second term, similarly, we have minus j pi in the exponent, and we have e to minus j 2k pi, again, coming from the second term over there. And again, when we evaluate the complex exponential at t equal to 0, we have 1. So we subtract 1 divided by j minus 1 minus 2k. Okay. Now, if we look at the terms in the numerators over these two expressions, here e to j pi is equal to minus 1, or e to minus j pi is equal to minus 1, and e to minus j 2k pi, so we have integer multiples of 2 pi, and therefore that term will be equal to 1. So in other words, this is minus 1. This term here is plus 1. Similarly, this is minus 1. This is plus 1. So we will have 1 over 2 pi j. So we have minus 1, we have minus 2 divided by j 1 minus 2k, minus, again we have minus 2 divided by j minus 1 minus 2k. Okay, now remember that j times j, we have this term in both expressions. J times j is equal to minus 1. We will have a cancellation with this 2, and j times j is minus 1. Therefore, these minus signs will also disappear, and we will have 1 over pi 1 over 1 minus 2k minus 1 over minus 1 minus 2k. So we can write this as 1 over pi minus 1 minus 2k minus 1 plus 2k divided by 1 minus 2k, and 1, let us write this as 1 plus 2k multiplied by minus 1, so we will have a minus sign here as well. So this will give us, now these terms will cancel out, we have minus 2 in the numerator, so we will have 2 over pi 1 over 1 minus 4k squared. So this will be the expression for the Fourier series coefficients of the periodic signal, which is the full wave rectified sine wave. Okay, thanks for watching.